3i Atlas has been found to change the jet stream it emits into space based on how it passes each planet. It's already close enough that it can be tracked rather than searched for, like a target. And that's when observers had an uneasy feeling. The object isn't just active, it's following a pattern. At first, it looked like a typical cometary quirk. The jet strengthened, then weakened. The tail was tweaked by the solar wind. A slight bend, a slightly different density, a slight asymmetry. A typical story for dirty ice and dust. But already on the second day, someone noticed a repetition. Not in the shape of the tail, not in the brightness, in the direction. The stream changed angle as if it were stepping along a scale rather than darting about in chaos. Precise, identical, too neat. Typically, a jet lives where it's lucky. A crack, a pocket of ice, a weak spot. The comet rotates, the heat spot fades, and the jet thrust fluctuates. In nature, there's no reason to maintain a uniform angular pitch like a ruler. The first alarming reports came from ground-based observatories. Different continents, different instruments, different teams, and the same phrase in the correspondence, the direction of the jet changed gradually, without a smooth transition. Some attributed this to data processing, others to a linking error, but when the same step was seen in independent series, the excuses began to run out. Errors rarely match in form. Then those who usually remain silent began to speak up. Those with access to observation windows that aren't available on request. High-resolution images, spectra, long series where the object is followed for hours without blinking. And that's where the main thing became clear. There weren't just one or two jets. Different emission sources were activated at different moments, but they didn't conflict with each other. They worked as a system that knew what it was doing. One source would go out, the second would turn on almost immediately, the third would give a short pulse like a marker. Then silence again, then the next angular step, and so on in a circle. Not according to the core's mood, but according to a schedule. The most disturbing thing was the tempo. The interval was too stable, give or take a few seconds, as if someone was holding a timer. That doesn't happen in a real comet. The sun, rotation, composition, cracks, all contribute to the noise. At first the steps seemed small, a few degrees here, a few degrees back, then the sequence stretched out. The angle of displacement became more noticeable, and then a word emerged, one usually whispered, even in scientific circles. Scan. Not a maneuver, not a chance, not a gust. A sweep is when you scan the space, move through a sector, record the data, and move on to the next one, like a radar beam, like a lidar, like a searchlight. When this word was first heard, many instinctively recoiled, because unfolding implies intention, and intention is no longer a question of astrophysics, but a question of who you really are here. The object didn't change the direction of the jet as if it were being pushed by external forces. It changed it like an operator selecting the next sector. Step, pause, impulse, step, pause, impulse. Moreover, the pulses varied in character. Some were long and even, as if maintaining a vector. Others were short, like signals. Still others were barely noticeable, but synchronous with the others, like service commands within a circuit. Then someone did something simple. He took the jet directions over several days and superimposed them on a sphere. Not just a picture, but rather geometry, where the jet actually points in space if you extend the vector. The result was a strange grid. Not perfect, but recognizable. Stripes, sectors, repeats, gaps. As if the object were passing along the meridians of an invisible marking and returning to the same lines. This grid wasn't tied to the comet's rotation in the usual way. The axis might precess slightly, the brightness might fluctuate, but the scan held. It was as if the system compensated for everything else and preserved the pattern, and then signals started coming from the other side. Not from optics or spectra, but from the radio spectrum, from zones where people were used to listening to noise and not expecting patterns. There too, they saw rhythm, not words or messages, too crude for that, more like an imprint of the operating mode, short modulations that coincided in time with the rotation of the jets, as if the same device were switching modes in two channels at once. It would seem that one could say, these are all interpretations, but the coincidence has become too multi-layered. Optics sees steps in direction, radio sees the rhythm of switching, the spectrum sees the repeated emissions of the train, and all this at the same tempo. On the third day, what always happens at such moments began in the closed channels. urgent calls, quick protocols, phrases without emotion but with a heaviness in the voice, and a list of questions that no one wants to read out loud. Why is the angle step stable? Why are the sources included as if they were interchangeable? Why is the direction chosen not by heating but by the diagram? Why are the pauses almost the same? Why does the pattern on the sphere repeat like a map? And the main question, which is not written in the reports, but which hangs in the air as clearly as a trace in a photograph, what exactly is it scanning? When it came to scanning, many tried to simplify it, calling it a reaction to the solar wind. But the solar wind is not a metronome. It doesn't produce perfect steps or repeatable sectors. Others have said internal crackling, pressure, surges. But internal crackling is not an architect. It doesn't draw a grid. It doesn't return to the same lines at the same pace. It doesn't pause, as if waiting for a response. Still others turn to mathematics. They try to deduce what kind of nucleus shape could produce such an effect. And there, too, a strange thing arose. For nature to produce something like this, symmetrical channels and switching mechanics are needed. That is, we need something that dirty snow should not have. Amid all this, the public sphere remained calm. The wording was familiar, safe, and rounded. We are observing activity typical of comets. No signs of a threat. We continue monitoring. It all sounded like nothing was happening, as if someone was deliberately making the speech boring so the listener's brain would shut down. And it worked for most people, but not for those who saw the numbers. Those who saw the raw data understood. This boring talk wasn't about calm. It was about control, about trying to keep the situation within bounds while it was still somewhat within bounds. And the unfolding continued. Each new step added another line to the pattern, another stripe, another sector. And the more lines appeared, the more clearly the thought emerged, making my palms grow uncomfortably cold. If it's a development, then there's a goal. If there's a goal, then there's a criterion. If there's a criterion, then the object doesn't just look. It chooses exactly what it needs. And then one analyst did a second simple thing. He didn't try to guess aliens. He simply asked, if I were a machine, what would I scan near Earth? There were many answers: magnetosphere, radio noise, ionosphere, reflections, radars, satellite paths, all at once. But one option looked particularly unpleasant precisely because of the pattern. Surface, not a photograph, but a map of active zones, where the signal is stronger, where the atmosphere behaves differently, where the field is off, where there are artificial structures that stand out from the natural background. And then he superimposed the scanned sectors onto Earth's geography, roughly without perfect precision, simply to see where the lines would point if extended toward Earth. The coincidence wasn't direct enough to scream about it to the world, but it was enough to silence the room, because some of the pauses in the scan occurred in areas that never like pauses, zones where signal density is higher, where there's more infrastructure, where the airwaves are thick with noise, where there's something to listen to, something to count, something to compare. It was there that the scan was delayed for a second longer. It was a small thing, a tiny delay, almost nothing. But in a system that already behaves like a device, almost nothing becomes the most terrifying detail, because it already resembles a reaction. It's as if the object isn't simply drawing a pattern for the sake of beauty. It's as if it's receiving feedback, as if it's changing the pulse duration when it sees what it needs. And if this is so, then we are no longer observers. We are part of the process. We are an element of its experiment. The unfolding continued for another day without faltering, and on the next turn, it returned to the beginning of the pattern. But it didn't return perfectly. There were subtle differences, a shift of one step, a slightly different order, a slightly different duration. It looked like the system had updated its plan, like it had received the data and decided to scan differently. This means that someone there, inside the shell of dust and ice, either very smart automation or something else, has already made a conclusion. And that was the moment when, over a closed channel, a phrase was uttered that would take the breath away from any adult. It was spoken calmly, almost casually, but the meaning was like a blow. It repeats the sweep but refines the pitch, just like after calibration. The problem is that deployment isn't just a fancy word. Deployment always has a purpose, and it almost always means two things at once: collecting data and testing the environment's response. Collecting is when you look. Testing is when you press lightly and see what happens. And it was here that the coincidences began, which made it impossible for people with access to real data feeds to joke. At first, it seemed too familiar to be alarming. A storm had passed somewhere, waves had risen somewhere, a storm warning had been issued somewhere. These things happen in December, and the world is a big place, with always something happening. But then a rhythm emerged in these ordinary events, not a global cataclysm or the end of the world. Instead, small bursts, distributed across the planet, as if someone wasn't trying to destroy, but rather to measure. Oceanographers call it noise, seismologists call it background, meteorologists call it vibrations, and only when there's precise repeating action in space nearby does the word background acquire a negative connotation, because the background begins to behave like a response. Observers notice the following. After each step of the sweep, when the jet changed direction and gave a short pulse, after a while, bursts were recorded in various systems across the Earth. Not in one place, not along one fault line, not in one ocean. At different points, as if someone were observing the reaction of the entire planet at once. And that was the worst part, because if the event had been local, it would have looked like a coincidence. But distributed events, timed to coincide with an external rhythm, look like a test. At first, suspicions focused on the magnetosphere. This is the purest bridge between space and Earth, requiring no science fiction. The solar wind strikes the magnetic shield, creating geomagnetic disturbances, and then everything sensitive to these fields begins to drift. But the problem is that the solar wind during these hours wasn't unusual enough to explain the synchronicity. It was active, yes, but not so active as to produce precisely measured, repeating kicks at regular intervals, and the scan gave exactly the dosage. If someone wanted to politely measure the magnetosphere, they wouldn't just look at it, they'd excite it, with gentle pulses, in precisely different directions, and see where the response was strongest. From that moment on, the word scanning ceased to be a metaphor. It became a working hypothesis, because the hypothesis explained too much with a single movement. The strangest thing was how the scan itself changed. It seemed to have two modes. The long mode, when the stream lingers, seemingly illuminating the sector, and the short mode, when a pulse, a marker, a signal is emitted. The long mode could be a measurement. The short mode, a calibration. Someone compared it to how a LiDAR machine collects a point cloud. Long passes, then test flashes to check if the machine has gone astray. And then someone took a third, simple step. He didn't argue about the mechanisms. He simply compiled a table, the time of each jet switch and the time of each noticeable response in Earth systems. Not any event, but events that statistically aren't required to form a chain. And the table turned out to be too beautiful. Not perfect, but enough to make the room very quiet. There's a pause after the pulse, and after a certain time window, messages begin to pour in. Small seismic tremors in various regions, sharp jumps in ionospheric parameters, unexpected gaps in radio communication on certain routes, bursts of aurora borealis where it shouldn't have been so pronounced. If it happened once, we'd forget about it. Twice, we'd write it off for the season. But when it happens again after a series of impulses, one nagging question pops into your head. What exactly is he pulling? Because the Earth's reaction didn't feel like a hammer blow, more like a gentle tap with a probe. Like a test. Does it respond here? What about here? What if it's a little stronger? And the sweep did indeed increase slightly in certain sectors, where the response was more pronounced. This was evident in the intensity of the emission and the duration of direction retention. That is, the object didn't simply pass by on the map, it lingered where it found its way. The most frightening thing is that the interesting coincided not only with the radio noise density. In some cases, it coincided with zones where the Earth system is already sensitive. Faults, large ocean fronts, areas of strong currents, and zonal corridors of the atmosphere where storms gain strength faster. Coincidence could explain one coincidence, but not the repeated squatting, precisely where the Earth responds most quickly to external stimuli. And it was at this point that big tools entered the conversation, not because they believe, but because they are obliged to verify. When serious telescopes are brought into play, everything changes immediately, because there's no such thing as seemingly. There are timestamps, pointing accuracy, independent channels, and most importantly, the ability to track an object continuously, and then the world saw what amateurs and small observatories had not noticed before. The jets didn't simply change direction. They left behind a structure that, when combined, looked like a repeating pattern. Not a chaotic tail, but a trace that could be statistically identified by stacking the frames over time. This pattern didn't resemble typical dust fans. It looked like a system of lines, the intensity of which was repeated at intervals. If you imagine the stream as a brush, the object wasn't drawing a cloud, but a line. And when independent teams saw this, the coincidence became an official issue. Within closed channels, rapid attempts to zero out the fear began. This is a normal reaction. People begin to look for simple physical causes to return the world to normal. They talked about precession, the shape of the core, the different compositions of the ice, microcracks, and reactive torque. All of this could explain the unusual activity, but it all fell apart at the word step. Real natural processes don't like a steady pace. They prefer smoothness, noise, and drift. Here there was a discrete set of positions as if the object had fixed guidance modes, and if an object has modes, then it has control. Not necessarily intelligent. Even automatic control is a different quality. It's no longer a stone, it's a machine. It gets worse. Because if this is a device, then the jet isn't just pretty. It's an engine. And an engine that works not like a comet's, but like a system that maintains a vector. This means that unfolding can be more than just a measurement. It can also be a real-time trajectory adjustment. And then one detail hit harder than all the others. During one of the sweep cycles, the object paused. Not the usual pause between steps, but a long one, as if awaiting results. During this interval, a series of events occurred on Earth that were difficult to ignore, even for those accustomed to statistics. Not a single tremor, but several weak tremors in different regions. Not a single storm, but a series of storm warnings issued almost simultaneously in different ocean basins. Not a single ionospheric oddity, but a pronounced break in the behavior of the layer that influences radio waves. And all of this fit into the time window after the pause, as if the object was looking at what he had done and analyzing the response. From that moment on, a new, unpleasant phrase began to appear in conversations: response checking. This is no longer a guest, this is an experimenter. But the most dangerous part was yet to come, because in the next scan cycle, the object changed the order of its steps. It repeated the pattern, but with a twist, as if it had finally realized which sectors were more important, and it reorganized its route to spend time not evenly, but prioritized it. It looked like it was optimizing the scan, and optimization means it learns. It doesn't just fly by, it receives data, draws conclusions, and changes behavior. And then, during one of the closed calls, a proposal was made that many initially brushed off and then stopped arguing. We need to see if the scan matches the trajectories of our orbital systems, satellites, stations, radar cones, any regular sources it could read. Because if you can scan not the Earth as a stone. You can scan infrastructure, and then your scan will follow not faults, but the grid of human activity. And if the object already distinguishes our grid, then the question becomes very simple and unpleasant. Is it scanning us as a planet or as a civilization? The first hours of the scan could still be explained by strange cometary activity, a complex nucleus shape, unpredictable outgassing, and rare geometry. But then a layer appeared that always obliterates these more straightforward explanations: orbital geometry. When you look at the jet's trajectory not as a pretty tail, but as a set of vectors in space, you suddenly realize that they may not be artistic. They may be targeted, and then the simplest question becomes, where exactly are these vectors directed, if you recalculate them onto the celestial sphere? The answer turned out to be too inconvenient. The sweep's step vector didn't simply wander across an empty sky. It significantly more often fell into areas where dense orbital paths were currently passing. That is, not simply toward Earth, but along the directions where entire clusters of satellites rise and fall above the horizon of various stations and radars. Low orbit, medium orbit, geostationary orbit, where our infrastructure moves. It was like a person in a dark room, shining a flashlight not randomly across the walls, but along the shelves, where he expects to find objects. And this is where many people really got tense for the first time, because an object like a strange comet is one thing. An object that behaves as if it sees our regiments is quite another. The meaning of the sweep began to emerge through its repeatability. The jet didn't simply comb the sector, it returned, at regular intervals, as if executing a cycle, sweep the zone, collect the response, return to the control points, and verify the calibration. The control points also turned out to be troublesome. They coincided with directions that appear empty in the sky to the average observer, but in fact, they regularly contain communication windows, areas where, given a certain geometry, radio links are best positioned and where data transmission routes between regions are established. At first, it seemed like a subtle statistic, bordering on you're imagining it. But then something happened that destroys any argument. One of the sweep steps occurred at a time when hardware connections were simultaneously passing over several geographically distant points. After the pulse, glitches began, which looked too similar to one another to be attributed to coincidence. Not a complete communication failure, but brief gaps and strange distortions. It was as if the signal was passing through a medium with changing parameters for a split second. If you want to understand what's going on, you don't look at the panic-mongering news, you look at the telemetry, at the correction errors, at the noise structure, at how exactly the signal is breaking down. And then, one unpleasant detail emerged. The interference was narrowband and appeared synchronously with the sweep pulse. That is, it wasn't a broad storm of interference from the sun, nor chaotic atmospheric noise. Rather, it was as if, at a certain moment, a neat insert appeared in a certain range. This doesn't look like a natural storm, but rather an impact, like a line test, like an attempt to understand how we transmit data. This is where serious names entered the picture, not as brands, but as facts. Because when something happens with such synchronicity, the first thing you do is bring in independent observers. The more independence, the less likely you are to be caught in an illusion. Large ground-based observatories began tracking the object continuously. Radio telescopes began monitoring not only the tail but also its spectrum. Professional astrometric networks verified the trajectory and recorded microshifts that could explain the jet pulses. And at that moment, the second part of the scan appeared. It wasn't about the jets, she was about time. What's important to understand now is that when different telescopes in different countries see the same anomaly at the same time, it's not just a wow moment. This is the point where excuses end. Different instruments, different atmospheres, different people, different data processing filters, and yet it still matches. This point didn't arrive at a climax, but rather routinely, almost quietly, because data always arrives quietly. Panic comes later. During one of the sweep cycles, the object made what appeared to be a kink in the graphs. High-resolution images showed that the jet hadn't simply shifted. It had shifted and remained in a position that didn't match either the previous step or the expected rotation dynamics. It was as if someone had pressed lock on a new sector. This fixation did not last long, but long enough for it to be caught by different groups. First, they marked the South American stations, then the European ones, then the Asian ones. Then came the verification, the timestamps matched. The difference wasn't in hours, it was in seconds. This meant one thing: the event was actually happening at the object, not in our instruments. At the same hour, almost simultaneously, radio telescopes detected a change in the spectral signature. Not a new substance, not a sensation, but a small but distinct shift in the lines. It was as if the emission mode had changed, and the composition or temperature of the jet had also changed. Second by second, different ranges, different methods, same point in time. And this was truly dangerous because now history acquired the structure of an operation level, not an anomaly level. Operations always have a sequence: preparation, calibration, action, evaluation. The event at this hour looked like an action. The detection of the jet coincided with the start of ionospheric surges at several latitudes on Earth during the same period. Not just one region, but several. And again, there were no signs of the solar shock that would normally explain this. If you want to pierce the ionosphere to see how it behaves, you can do it with a signal or a field or a stream of charged particles. And if you have a narrowly focused emission in space and you can hold it at a point, then you can do exactly what looked like a pulse on the graphs. This was the moment when people started talking not about a comet, but about a regime. Regime is the word of engineers, not astronomers. And when engineers come to astronomy, it means someone has stopped believing in chance. Then another unpleasant shift occurred. At that same hour, the object briefly stopped, combing the space evenly. It seemed to have made a choice. He maintained a course along the celestial paths that connected him to major communications and navigation hubs. It wasn't mystical kilometer-level precision, but it was accurate enough to cover a sector. And a sector is enough to say, he knows where something is. And at that moment, a classic reaction set in among those responsible for the public. Don't amplify, don't accelerate, don't give people a starting point from which to fantasize, because even if it's not a machine, the very synchronicity and regime makes the story toxic. And so, familiar phrases began to be heard in the public sphere, observations continue. Nothing outside the bounds of natural behavior has been recorded. The data is being clarified. But inside, it sounded different. Inside, it was, we have an independent coincidence. We have a regime change. We have traces of impact on Earth systems in the post-pulse window. We cannot ignore it. And here comes the most nerve-wracking part of the story, because then the object does something that looks like a response. Not the sun, not gravity, but what we've started to see, against the backdrop of that hour, people within the observation networks had one desire: to eliminate the human factor, not because we're afraid, but because coincidences in science can only be cured by one thing: blind protocols. The idea was simple and straightforward. Several teams in different countries are switching their telescopes to a schedule where pointing windows are chosen in advance, without reference to past outbursts. No, let's look at the same place again, just a schedule. If the object behaves like a natural one, the coincidence statistics should disintegrate. The jet will flash anywhere, anytime, and our windows will sometimes hit, sometimes not. It should become noise, not a pattern. The first 24 hours provided just the right amount of reassurance. Some of the windows were empty. No vivid fixations, no strange sense of direction. It was even possible to breathe a sigh of relief and say, "Great, we've worked ourselves up." But then the worst thing happened. The second series of windows, now on a blind schedule, suddenly began catching impulses precisely at the moments of targeting. Not often, not every time, but more often than it should. It wasn't magic or he hears us. It seemed worse. As if the object wasn't guessing our actions, but rather reading the conditions under which we become observers, and reacting to the very fact of observation. Look, what's so scary about that formulation? If you're responding to our radio communications, you should be able to hear them. If you're responding to our telescope commands, you should be able to intercept them. But here, the response was to geometry. Geometry can't be eavesdropped in the conventional sense. It can only be seen. That is, you either observe us as we observe you, or you have a different channel of perception. And this is where the heaviest instruments come into play. Not for the sake of their catchy names, but because they offer something amateur networks lack: absolute time alignment and standard calibration. Data from large optical systems began to be merged with radio and spectrum data. A timestamp was inserted into each sweep pulse, and an attempt was made to answer a question that usually sounds boring, but here became dangerous. Is there a code in it? When you're looking for a code, you're not looking for words. You're looking for a repeatable structure. Rhythm, errors that repeat identically, insertions of the same length, pauses with the same pitch. And the structure was found too quickly, not as a message, but as a sequence of modes. Low power, hold, reset, next step. It was like a scanner going through layer after layer. Then someone did what they always do in such situations. They tried to break the observation, not by interfering with the subject, but by changing the conditions to test the reaction. Some teams eliminated any predictable patterns: random windows, varying exposure lengths, different filters, delays between measurements. Ideally, the subject should remain itself, and we should cease to be a clear target for it. And then the pattern changed. It became less smooth, but more targeted. The footsteps began to thicken in narrow sectors of the sky where at that time there were paths that the comet wouldn't normally be interested in. It was as if he first mapped the space and then chose what exactly he needed in the map. Scanning as reconnaissance. Scanning as a search for what responds. The most disturbing thing appeared at the intersection of the two types of data. The optics showed a stream of interference, while the radio simultaneously showed a thin line of interference like a needle. Not a storm, not noise, a neat insertion. If this were solar activity, it would have smeared everything. If it were the atmosphere, it would have produced chaos. But here there was a narrow, repeatable trace that only appeared with the pulses. A new word appeared inside the observers: response. Not because the object talked, but because it changed its behavior after the experimental conditions were changed. This is the key distinction between randomness and system. And just as people started talking system inside, the opposite was heard outside. Calm phrases, neutral comments, no drama. That's what they always do when they don't want the crowd to predict the outcome before the data. The problem was different. even without being spoken out loud, mathematics itself ceases to be neutral. The blind graph should have blurred the coincidences. Instead, it emphasized them. This is what led to that very closed conference call, where people from different departments sit and try not to argue about meanings, but to resolve practical issues. How do we monitor the situation further without becoming part of the process? Because if the object truly reconfigures its unfolding to suit our conditions, then each new attempt to refine the data can make it more accurate. You're studying it, but you're also training it. And then there's only one move left, one that seems cruel but logical. Complete blind mode for several cycles, minimum emissions, minimum active commands, only passive locking where possible. If at this point the scan not only remains but becomes even more precise, then it doesn't need to listen to us. It's enough for it to see us as a target on the map. And then the main question ceases to be scientific. It becomes mundane and frightening. If this is a scan, what will happen when it's over? The third cycle of silent windows began without any heroics. Minimal commands, minimal active lighting, minimal unnecessary radio, only passive collection, only checkpoints and strict timestamps. The logic was simple. If the coincidences disappear, then we were creating the pattern ourselves, adjusting to the rare flashes. If the coincidences remain, then the pattern exists independently of us and merely uses us as sensors. The first hours look smooth. No needles in the radio, no perfect flow control. Just the usual dirty statistics that are so nice to see when you're tired of being afraid. That's why the blow was so much stronger. It came not as a powerful flash, but as a series of tiny, almost embarrassing signals that, by themselves, mean nothing until you line them up. One pulse arrived at the edge of the window, just as the system was already moving away from the target. The second arrived right in the middle of the silence and Nolzama when no one should have detected anything at all. The third was in phase with the first. It was the same scanning rhythm, only seemingly at a reduced power, like a communication check mode, as if the object didn't want to glow, but wanted to make sure the space around it was still responding. Then the most unpleasant thing happened, cross-correlations. Several independent groups without sharing details ran the same time series through different filters. And everyone saw the same thing. The pulses weren't directed at telescopes, stations, or cities. They were directed at geometry, at those moments when the Earth turned the same area toward the object. It sounds harmless until you realize what it means. He wasn't choosing when we look, but what exactly he sees of us. The vantage point wasn't ours, but his. At this point, Hubble emerged in the discussions not as a symbol, but as a disciplinary tool. Its data cannot be randomly adjusted, because it has a different level of calibration and different control over system errors. Hubble didn't offer salvation, but rather confirmation. A subtle ejection pattern in one of the cycles repeated itself at the same angle as before, only slightly shifted, as if the object were running the same pattern through an adjacent sector. Meanwhile, on Earth, major observatories did something they usually dislike. They acknowledged they couldn't figure it out on their own. And so they began exchanging protocols, not opinions. Who was filtering things, what they were checking time with, where they were setting thresholds. At the same time, someone insisted on a rigorous check of external causes, solar wind, radiation belts, atmospheric effects, local interference, satellite paths, anything that could produce a false pattern. The more noise was removed, the smoother the drawing became. And this was worse than any sensation. A sensation can be attributed to a mistake. A smooth drawing after cleaning has nowhere to be attributed. After this, a new thought arose within the group, one that no one wanted to voice first. Perhaps the unfolding isn't an observation of emptiness. Perhaps it's seeking a specific response from us. Not a radio signal in the human sense. Any response. Magnetic, plasma, gravitational microshift, any signature that distinguishes a living planet with a technosphere from stone. And then they began to look for asymmetry in the data, not beauty, where the sweep accelerates, where the step decreases, where the repetition is more frequent, because that's how search works. You slow down where you find a trace. The asymmetry was found in an area that shouldn't have been of interest to a comet. Not near the Earth's poles, not in the direction of the sun, not the classic brightest spot. It lay in a narrow arc around the planet. This arc coincided with the region where the density of orbiting objects is highest. That's where we have garbage, spacecraft, communications networks, and everything that makes Earth a noisy machine. No one said, "He's studying satellites." That would have been too blunt. They said something else. Perhaps he's reacting to artificial structures because they give a consistent response. And almost immediately, as if in response to the very thought, the scan changed mode. The jet stopped drawing wide steps and began making short, frequent switches as if drawing a fine outline. It looked like an attempt to outline something in space. It was as if the object was detecting the boundary where the signal changed and moving along that boundary, refining its shape. The most disgusting thing was that this accuracy grew visibly. With each cycle, the switching became smoother and the pauses became more uniform. It was like a calibration that completes the setup of an instrument before operation. At that moment, the discussion within the conference center stopped about the nature of the object. They began arguing about observation tactics, because if this was calibration, then action mode would follow, and then our role as observers would become secondary. The decision was unpleasant, but rational. For several hours, some ground systems had to go into a maximally passive mode to see if the object would lose its contour without our collective, noisy activity. And then, something happened that shattered the familiar sense of security. The outline didn't disappear. It simply began to draw more slowly, as if the object were patiently holding the model while the environment changed. It no longer resembled a comet. It resembled a device that maps the planet and then tests its stability when conditions suddenly become quieter. Toward the end of this episode, another coincidence occurred that left everyone in the room breathless. One of the sweep pulses coincided with a brief gap in one of the control communication channels. The dip was too brief to be considered an accident and too clean to be a fluke. It looked like a momentary loss of synchronization, as if someone had jerked the reference for a second. No one said interference out loud. They said carefully, synchronization anomaly. But everyone heard the same thing. If an object is capable of influencing the measurement conditions, we no longer guarantee the purity of the data. And here's where the story returns to that hour. Because that hour isn't just a coincidence, it's a window when independent instruments not only see the same thing, but are forced to acknowledge. We're observing a system that takes observation into account. There was only one step left, and it was the most dangerous for reputations. To switch some of the observations to a mode where the data is recorded locally and disclosed later, to eliminate the effect of collective adjustment. If, after the reveal, the pattern is found to match again, then the device version dies completely. Only the behavioral version remains. By morning, the painting had become so clear that it could no longer be explained. Not because it was loud. On the contrary. It was too quiet and too uniform, like a signature someone signs with the same hand every time. It wasn't humans who gave in first, but mathematics. Several centers independently ran time series using different methods, and the same pattern emerged everywhere. The pulses coincided with the same phases of the Earth-object-Sun geometry. Then the worst began. The patterns coincided across different bands. The optics produced a thin bridge in the tail. The radio picked up a brief flicker in the spectrum. Millimeters produced a burst of lines, and all this from a single window. This was the kind of situation where it no longer mattered who was the first to shout anomaly. What mattered was that independent instruments, not necessarily supposed to be friends, suddenly began speaking the same language, matching the same seconds. From that moment on, the device acting up died completely. Because mirror shake can't be blamed for what's simultaneously visible in Chile, in orbit, and in the radio range, where the atmosphere is completely absent. And then a new hypothesis was born, one that's unpleasant to even read. The scan doesn't just scan, it synchronizes. Not with us, but with the way our observation network is structured. We have a habit of working in batches. We all switch according to a schedule. We're all tied to the same time. We all use the same communication windows, and if the object understands this, it can enter not the telescope, but the system. What happened next is usually hidden behind the dry words internal channel. Several places simultaneously imposed a ban on discussing precise timestamps in public messages, even between colleagues. Not because it's a secret for the sake of it, but because any schedule leak turns the entire network into a target. If an object responds to synchronization, we ourselves draw a map of our eyes for it. An hour after this ban, the scan rate changed again. It became less frequent but more precise, not a broad brushstroke, but careful touches, as if the object had stopped searching and began confirming what it had found. The scariest part was that the confirmation came not from brightness, but from reaction. Where we changed the observation mode, the object changed the jet mode. Where we remained silent, it didn't fade, but held its shape, as if waiting. Then came that line no one wanted to see. Several observatories obtained identical microstructure in their data, as if the signal had been modulated in the same way, but on different carriers. It wasn't a message in the human sense. It was like a barcode. Repeat, pause, repeat, long pause, repeat again. Not text, but a signature, and the worst part was, the signature was repeated twice. Then it became clear why the sweep was necessary. It wasn't a looking at us, it was adjusting the parameters. It tried different steps in different directions until it found the mode in which the Earth responded most consistently. After that, an emergency call became a matter not of interest, but of responsibility. Because if an object can adapt to the network, the next step is logical. It can force the network to adapt to it. And then, for the first time, a word that's usually not uttered without evidence entered the conversation: influence. Not explosive or fantastical, but a quiet, engineered influence on observation conditions, on synchronization, on our habits. At this point, one of the participants uttered a sentence that sounded like a death sentence. We argue about the nature of the object, but we act as if it's stupid. But the data shows that it learns faster than we're used to. By evening, it became clear that the perimeter flyby and sweep were connected. It wasn't by accident that he avoided the most convenient angles. He planned the route so that we saw exactly as much as he needed for tuning. And then the most unpleasant dilemma arose. Either we continue to show him our system and get a pretty picture, or we suppress some of the activity and risk, missing the moment when he switches from calibration to action.